Hi again. So we're going to finish up our discussion of maps by discussing map projections. Okay, so a map projection is the way that we take something like the globe and put it on a flat piece of paper. So we're going from 3D to 2D. And what's really important for you to know about that is it's impossible to do accurately. And so cartographers have to decide what they want to preserve because something is going to be inaccurate when they have to flatten something like the globe, right? And so when we're talking about map projections, you're most likely going to have to analyze some sort of distortion, right? Something that gets messed up because of its projection. There are a bunch of different styles of map projections, and I'm going to show you a few. So that way you can kind of see how to analyze distortion. But a good way for you to remember the idea of map distortions is SAD, SADD, SAD. So a map projection is likely going to distort either the shape of continents, right? The area, meaning the size, the direction between them or the distance between them, okay? And so there are some maps that the direction is not going to be correct. And if you used it to sail on the sea, you would be completely lost because the cartographer was making a specific decision that he or she wanted to conserve and not mess up maybe the area of the continent or the specific shape. So let's talk about some examples. Here's the first one. It's called the Mercator map projection. And what I want you to focus on when we're looking at these map projections is typically two areas, Greenland and Africa. Okay, these are the two indicators that you're mostly going to use to figure out where these distortions are occurring. So if we look at the Mercator projection, some things that you need to know is that it is very old. It was created in about 1569. And an advantage here, and something that you should know for context, is it was actually created by this German named Mercator because he wanted to be able to easily navigate at sea. This is kind of like the standard for sea navigation in terms of map projections. And the way that he made distance and direction so accurate, right, or as accurate as he could, is he made clean right angles of latitude and longitude, right? So latitude going this way, longitude going this way. And those clean right angles make it really easy to read if you're trying to navigate, and it helps kind of preserve that direction and sometimes the distance. Now, what else is good about Mercator is that the shapes are pretty accurate of the continents, but here is a big disadvantage. The size or the area, right? The A in SAD, the area is very inaccurate. When you look at the North Pole and the South Pole, that area gets very, very stretched. And so what that does is it makes countries closer to those poles look much larger. And so a lot of people have accused this Mercator map projection of having a Western bias, right? Because it preserves the size here of Europe. However, it greatly minimizes the size of Africa as well as South America, and it greatly increases the size of Russia and Canada and the U.S. Now, that's why I told you to pay attention to Greenland because Greenland is so large in this map. It looks like it's almost larger than Africa, and it is nowhere near that size. So this is the Peters equal area projection. And so before I talk about it, I just want to show you here the Mercator map projection is in black and the Peters is in green. Look how very different these map projections actually are. So let's talk about the Peters. I said pay attention to Greenland and Africa. Look how much different they look on this map than they did on the Mercator. So the Peters equal area projection was created in 1967, and the intention behind creating it was to take away and remove this Western bias that a lot of people accuse Mercator of having. But here's the thing. What they've decided to do with the Peters map projection is preserve area, right? So the actual size of these continents are correct. And so you can see Greenland is actually much, much smaller than the continent of Africa. However, nobody knew that only studying those Mercator map projections. And no map projection is perfect though, right? So we can see here the shape of these continents is greatly distorted. So the shape is much better on our Mercator. You can see the example here. However, the area is what they were attempting to correct. And so they've sacrificed shape. Now, you also don't want to use this map to sail anywhere because direction and distance are completely inaccurate. So as you can see, when we compare and contrast these two, map projections have arguments, right? They are kind of these sources that we have to look at and analyze rather than just take as true. So here again, you can see Peters is green, Mercator is black. Look at the huge differences. Okay, the Robinson is the next one that we want to talk about, and this is kind of the most widely used map today. It's known as a really good compromise because when it was created, the intention was to create a balance between those sad distortions, right? And so we see size and shape kind of balanced here. And it's pretty visually appealing. It doesn't look awkward like the Peters does. But here's the thing. Since it's trying to be balanced, it actually gets nothing 100% correct. So, you kind of have to decide, what do I want to alter? What do I want to make sure stays accurate? And so with the Robinson map, they've just decided that they want to balance everything out. So that means everything is distorted. Shape, area, distance, and direction. And you can see very similarly to our Mercator, at the poles, things get a bit stretched out. Okay, here's the last one that I want to talk about. This one's kind of crazy for a lot of people to look at. It's Amuthal is how it is pronounced. Nomic is another way that it's discussed. It might also be called Konak, but the name of it is less important than understanding its distortions, okay? So this is actually used as the United Nations logo, which is quite interesting. And it was originally created for navigation in the polar regions. So it does show accurate direction in these polar regions, but check it out. It's almost like you're standing on top of the world and you're kind of looking down at it. And so, shape, area, all of this gets massively distorted as we move away from the central pole here in the center. So you may not even be able to recognize. Sorry, announcements. You may not even be able to recognize like the continent of Africa or North America or South America here. But like I said, even though it may be good for navigation at those polar regions, it is increasingly distorting things like shape, area, and distance as you move out from that central polar region. Okay, so we are good for maps. Thank you so much, and I will see you soon.